What if I told you that 95% of what's out there is invisible, completely undetectable, and yet it controls the fate of everything? But that the greatest secrets of our existence might lie inside the objects so strange they defy the very laws of physics. Please watch till the end because today we are unraveling the 5 most mysterious questions of the universe, and trust me, your mind will never be the same. For centuries, humans have gazed at the stars, asking why are we here and what's out there. The deeper we explore, the more the universe surprises us with its enigmas. From dark matter binding galaxies to the unexplained Big Bang to the tantalizing possibilities of extraterrestrial life, the mysteries grow more complex. So join me as we break down the 5 biggest mysteries of the universe. Get ready because these mysteries are far bigger than we can imagine. First of all, what is dark matter and dark energy? Have you ever thought that why the galaxies stay together? I mean, think about it. There is so much empty space, and yet galaxies aren't just flying apart. That's where the dark matter comes in. It's like the invisible glue holding everything together. Scientists first got the clue about this back in 1930s when this Swiss-American astronomer named Fritz Zwicky noticed something odd. He was studying the galaxy cluster and they were spinning way too fast for their visible mass to hold them together. It was like watching a merry-go-round that shouldn't have flown apart but didn't. So Zwicky said there must be something we can't see keeping them in check. But it wasn't until the 1970s when Vera Rubin, a trailblazer in astronomy, studied spiral galaxies and found the same thing. The stars at the edge of galaxies were moving just as fast as the ones near the center. Without dark matter, those galaxies would have unraveled like loose thread. Dark matter has been detected in other ways too. Gravitational lensing, for instance, where light bends as it passes through the massive invisible objects, tell us it's out there, even though we can't directly see it. But dark matter doesn't stop there. It's not just a galaxy glue, it also shapes the entire structure of the universe. Large-scale surveys of the universe shows that dark matter acts like a scaffolding around galaxies, dictating their growth and interaction. Without it, the universe would look drastically different. There is even a theory suggesting that dark matter might be a reason for the formation of large cosmic structures like clusters and superclusters of galaxies. Without dark matter gravitational influence, these massive structures could never have formed in the way we see them. So what exactly is dark matter made of? Well, no one really knows. Some scientists think that it might be made of particles called WIMP, weakly interacting massive particles. These particles don't interact with normal matter in the way we are used to, which is why we can't see them. It's like they're ghostly, barely touching anything, but WIMPs are tricky. They are incredibly hard to detect because they don't emit light and they don't interact strongly with the stuff we can see. Other theories suggest dark matter might be made of axions, extremely light particles. They are almost impossible to detect. There is even a possibility it could be sterile neutrinos, a type of neutrino that doesn't interact with normal matter. Experiments like Large Hadron Collider at CERN are constantly on a hunt to find any trace of these particles, but so far nothing concrete. Now let's talk about dark energy, the even wilder concept. Imagine this, in 1998, scientists studying supernova, a kind of exploding star, found that the universe isn't just expanding, it's speeding up. That's like throwing a ball in the air and watching it fly faster the farther it gets. Saul Perlmutter, Brian Smidget, and Adam Rees, the folks behind the discovery, were baffled. They won a Nobel Prize for their work, but the mystery remains. What's causing this cosmic acceleration? Dark energy is the name we have given it, but honestly, it's just a placeholder. We have no idea what it is. So what's causing dark energy's effects? Well, some scientists think it's a property of space itself, a kind of energy that exists even in the emptiest vacuum. This idea was initially suggested by Einstein, who introduced the concept of cosmological constant as part of his general theory of relativity. He originally thought it was a fudge factor to keep the universe from collapsing under gravity, but after discovering that the universe was expanding, he declared the idea. However, dark energy has brought that concept back into the limelight, now seen as a fundamental property of the cosmos. Others suggest that dark energy could be a new kind of energy field that we have never encountered before. Maybe it's a linked quantum mechanics in some way, or perhaps it's related to vacuum energy, the energy that exists even in empty space due to quantum fluctuations. One of the biggest questions is, if dark energy is responsible for the accelerated expansion of the universe, what will happen in the future? Will it keep speeding up until galaxies are torn apart? Some models predict an eventual big rip where dark energy grows stronger, causing a fabric of space itself to stretch to a breaking point. Stars, galaxies, and even atoms could be torn apart in the process. Scary, right? Some scientists think that dark matter might be made of particles called WIMP, weakly interacting massive particles. Others think it could be something called oxyons or style neutrinos. One of the most cutting-edge experiments in the hunt of dark matter is Lux Zeppelin, an experiment set to detect WIMPs in the deep underground lab. Then there is the Exion 1T experiment, which is also trying to detect dark matter particles in the lab filled with liquid xenon. So far, all attempts have yielded no results, but the hunt is far from over. As for dark energy, there are tons of theories floating around. Some suggest it's a property of space itself, while others propose that it's a new type of energy field that exists throughout the universe. The Euclid mission, launched by the European Space Agency in 2020, is mapping billions of galaxies in an effort to understand how dark matter and dark energy shape the universe. It's like a cosmic treasure hunt for the ultimate secrets of the universe. Did you know that the total amount of dark matter and dark energy in the universe is estimated to make up about 95% of all the matter and energy in the cosmos? That means everything we can see, galaxies, stars, planets, only account for tiny 5% of the universe. Makes you wonder what's out there, right? So while we don't have all the answers yet, the hunt of dark matter and dark energy is one of the most exciting quests in the modern science. Who knows, the next breakthrough could change everything we know about the universe and our place in it. Okay, let's dive into the next ultimate cosmic question. What happened before the Big Bang? The Big Bang theory tells us that around 13.8 billion years ago, the universe began as an infinitely dense point, expanding rapidly to form everything we see today. But here is a big question. What was happening before that? Physicist Stephen Hawking had a mind-boggling take on this. He said asking what happened before the Big Bang is like asking what's north of the North Pole. According to him, time itself began with the Big Bang. There was no before because the time didn't exist in the way we understand it. However, not everyone agrees with that. Now let's discuss some theories that will blow your mind. The multiverse hypothesis. Ever heard of Max Tegmark or Andrew Linde? These cosmologists believe that our universe could be just one of many in the vast multiverse. Imagine a bubble bath where each bubble is a universe and ours just happen to pop into existence. The multiverse theory suggests that multiple universes are constantly being created, and our Big Bang might just be a blip in an eternal process of the universe creation. If this is true, then there is no single beginning or end for the cosmos, just a constant churn of universes popping in and out of existence. Here is another fascinating theory. What if the universe isn't a one-off event, but part of an endless cycle? This is the idea behind the cyclic universe theory, proposed by the physicists Paul Steinhardt and Neil Turok. Imagine a universe constantly expanding and contracting in a never-ending loop. After each Big Bang, the universe would expand, then eventually collapse in a big crunch, only to start over again. This means that the Big Bang we know might not be the first one, and certainly won't be the last. Then there is a quantum gravity, a theory that could bridge the gap between general relativity and quantum mechanics. Physicist Carlo Rovelli suggests that instead of the universe originating from a singularity, the Big Bang might have been a result of a quantum bounce. In this model, the universe didn't start from nothing. It could have bounced back from the previous contraction. This challenges the idea of definite beginning and instead proposes that the universe has been through countless cycles of expansion and contraction on a quantum scale. Did you know that the great Sir Roger Penrose found unusual patterns in the cosmic microwave background radiation, the faint afterglow of the Big Bang? He called them Hawking points, and they could be traces of a universe that existed before ours. This discovery has sparked intense debate. Could these points be remnants from a previous cosmic cycle, hinting at a universe that's gone through multiple Big Bangs? If so, it would align with the cyclic universe theory, where time doesn't have a beginning or end, but is part of an infinite loop. Some cosmologists like Lee Somlin go even further and suggest that our universe might not be a unique event at all. Instead, it could be a part of a much larger cosmic process where new universes are born from old ones. In his cosmological natural selection theory, Smolin proposes that universes give birth to new ones through black holes. If true, it would mean that the universe you and I live in is just one link in a chain of cosmic creation, with each Big Bang potentially leading to a formation of a new universe and so on, forever. Other theorists suggest that what we are observing as the Big Bang could be just the birth of our observable universe, but not the birth of everything. Imagine that our universe is just a tiny pocket of space-time within a much larger multiverse. This would explain some of the bizarre phenomena we observe in cosmology. For example, dark energy and the accelerating expansion of the universe might not just be isolated to our universe, but could be a property of the entire multiverse, stretching across different dimensions or universes. And if that's true, then the Big Bang we are familiar with might not even be the start of everything. There could have been multiple Big Bangs, with each one forming a new universe, while older ones slowly collapse, leading to endless cycles of cosmic birth and death. Okay, let's dive into next one of the biggest mystery of all time. How did life begin? Was it just a lucky accident, or is life something inevitable in the universe? We know life began on Earth around 4 billion years ago. But the question is how it started is still one of the science's greatest puzzles. Let's take a look at what we know and what we don't. The spark of life. Back in 1950s, two scientists, Stanley Miller and Harald Urey, set up one of the most famous experiments in the history of science. They recreated conditions they believed existed on early Earth. Think lightning storms, volcanic activity, and a soup of basic chemicals like methane, ammonia, and hydrogen. Then they hit it with electricity, mimicking lightning. And what happened? They created amino acids, the building blocks of life. This was huge because it showed that basic organic molecules could form naturally under the right conditions. But here's the thing, amino acids aren't life. They're like the ingredients for life but not the finished product. So the big question remains, what turned these molecules into living cells? Scientists are still working on this, but one idea is that once the amino acids are formed, they might have linked up into more complex molecules like proteins and RNA. From there, these molecules could have come together to form the first simple cells. But how that exact process happened is still a mystery. Now here is another mind-blowing idea. What if life didn't start here on Earth at all? Some scientists think life could have come from space. This theory is called panspermia, and it suggests that life, or at least the building blocks of life, could have hitched a ride on comets, asteroids, or space dust, then landed on Earth and sparked life. In fact, organic molecules have been found in some pretty wild spaces on comets, asteroids, and even interstellar clouds. For example, in 2014, the European Space Agency Rosita's spacecraft detected glycine, an amino acid on the comet 67P. If amino acids can form in space, could life have traveled through space and settled on Earth billions of years ago? Some scientists believe it's a possibility, and if true, it would mean life isn't unique to Earth. It could be elsewhere in the cosmos, just waiting for the right conditions to take hold. People like Sarah Seeger and Jill Tarter are at the forefront of the search of life beyond Earth. They are pushing the boundaries of what we know about the life by studying extremophile organisms that can survive in the most extreme environments, from boiling hot springs to the freezing vacuum of space. These extreme organisms shows us that life is adaptable and might thrive in places we never thought possible. Astrobiologists are also studying the concept of biosignatures, chemical or physical signs that could indicate life. They are looking at exoplanets, orbiting stars outside our solar system, trying to identify planets that might have conditions similar to Earth's and could support life. NASA's rover is currently on Mars, actively looking for signs of ancient life. It's drilling into Martian rocks, analyzing soils, and hunting for any trace of past microbial life. If life ever existed on Mars, it could have been very different from life on Earth, but any discovery would be a huge breakthrough. Meanwhile, the James Webb Space Telescope is giving scientists a whole new way to look at exoplanets. Unlike the Hubble Space Telescope, Webb can peer deeper into the atmospheres of exoplanets to identify possible biosignatures like oxygen, methane, and carbon dioxide gases that might indicate the presence of life. And here is the kicker. Some scientists believe it's not just possible that life exists on other planets, it's likely. Considering there are billions of stars in the Milky Way alone, each with its own set of planets, the odds are that at least a few of these planets have the right conditions for life. The universe is vast, and we are barely scratched the surface in our search of extraterrestrial life. The more we learn about life's origin, the more it seems that life might be more common throughout the universe. Whether life began here on Earth or came from somewhere else, the fact remains that life is an incredible phenomenon, and we are just starting to understand it. Could life be out there waiting to be discovered? Maybe we are just a step away from answering that question. Maybe we'll find life not on Mars, but one of the countless other planets out there. The quest for the origin of life is still ongoing, but one thing is for sure. The search is far from over, and we might just find out that life is more widespread than we ever imagined. So the next fascinating mystery we are going to discuss is, why do black holes exist? Black holes are one of the most mysterious and captivating phenomena in the universe. They are regions where gravity is so intense that not even light can escape. But why do they exist, and what's inside them? Let's dive in. Let's start with how they were discovered. The concept of black holes goes back to 1916, when physicist Carl Schwarzschild solved Einstein's equations of general relativity and predicted the existence of objects so dense that they would distort the fabric of space-time itself. However, at the time, this was purely theoretical. The idea of objects that could trap light seemed almost too strange to be true. It wasn't until 1960s though that black holes began to shift from theoretical to observational. John Wheeler popularized the term black hole, and in 1964, Cygnus X1, one of the first confirmed black hole candidates, was discovered. This was based on the behavior of the object's gravitational pull on the nearby star. By studying the way the star orbits, astronomers realized that the object exerting the pull was incredibly dense, leading them to conclude it was a black hole. This was the beginning of a new era in our understanding of these strange and fascinating objects. So here are some theories about the purpose of black holes. Hawking radiations. Stephen Hawking introduced a revolutionary concept in the 1970s. According to him, black holes are not just completely black. They can emit a faint radiation known as Hawking radiation due to quantum mechanical effects near the event horizon. This means that black holes can gradually lose mass and energy over time. In theory, this radiation could cause black holes to slowly evaporate over trillions of years. The idea of a black hole dying may seem counterintuitive, but it opens up exciting possibilities for how they might behave over cosmic time scales. So the next theory would be wormholes. Some physicists propose that black holes could be more than just a destructive cosmic object. they might also be wormholes, shortcuts or tunnels in space-time that could connect distant regions of the universe or even link different universes entirely. While this concept sounds like something out of science fiction, it's mathematically possible within the framework of Einstein's theory of general relativity. In a sense, black holes might serve as a portal to unknown realms, opening up fascinating possibilities for space travel and the exploration of other universes. Now the next relevant theory is galactic architects. Black holes aren't just isolated phenomena, they might play a role in shaping the galaxies themselves. The supermassive black hole at the center of galaxy Sagittarius A is thought to influence the process of star formation. By emitting powerful jets of energy and radiation, black holes may regulate the conditions necessary for stars to form in the surrounding region. Without these cosmic giants, galaxies might look very different. In fact, it's theorized that black holes could even be crucial in maintaining the structural integrity of galaxies, helping them prevent from collapsing or falling apart. The next theory would be cosmic recycling. Another fascinating idea is that black holes could be a part of a cosmic recycling process. When a black hole devours a star, the material that falls in is crushed to an extreme density, and some of it may eventually be ejected back into space in the form of high-energy jets. This process could lead to the creation of new stars or the cosmic structures, contributing to the ongoing cycle of life and death in the universe. Now the question is, what's inside a black hole? At the center of every black hole lies the singularity, a point where space-time curves infinitely and the laws of physics as we know them ceases to function. It's a region of infinite density where matter is crushed into an infinitely small space. This is where things get truly mysterious. Once something crosses the event horizon, the boundary surrounding the black hole, it is lost forever. The event horizon marks the point beyond which nothing, not even light, can escape the black hole's gravitational grip. What happens inside the event horizon is still a matter of speculation because we have no way of observing it directly. Some scientists believe that black hole's singularity could be a gateway to another universe or even a connection to other regions of space-time. Others think it might be a dead end, where everything that falls in is irretrievably crushed. We simply don't know yet. Now here is the final big question is, are we the only intelligent beings in this vast, mind-boggling cosmos? The answer might be closer than we think, and the search for it is unfolding right before our eyes. In the 1950s, physicist Enrico Fermi posed a simple yet profound question. If the universe is so vast and old, where is everybody? This paradox highlights the contradiction between the high probability of extraterrestrial civilizations and the complete lack of direct evidence. Given the billions of stars in our galaxy alone, many of which have Earth-like planets, the question becomes even more puzzling. Why haven't we heard from anyone? Since the 1960s, scientists have been searching the skies for signs of intelligent alien life. The search of extraterrestrial intelligence, SETI, has been a driving force in this effort. One of the most famous moments came in 1977 when astronomer Jerry Ehman detected a powerful 72-second radio burst known as the wow signal. Despite many efforts, we still haven't been able to explain it. Was it a natural phenomena, a mistake, or possibly even an alien signal? The mystery remains unsolved, but it keeps the hope of contact alive. In recent years, the discovery of exoplanets, planets orbiting stars outside our solar system, has exploded. Thanks to missions like Kepler, we now know that many of these exoplanets exist in the habitable zone, where conditions might be right for liquid water and potentially life. One key area of research is the detection of biosignatures, chemical signs of life in the atmosphere of the distant worlds. Scientists like Sarah Seeger are working on new methods to spot gases like oxygen, methane, and carbon dioxide that could indicate the presence of life. Astronauts have had some profound experiences that makes us rethink our place in the universe. Chris Hadfield, a Canadian astronaut, shared his experience of the overview effect. the realization of how fragile and interconnected life on Earth is when viewed from the space. Looking down at our planet, suspended in the vastness of space, it's easy to wonder if there is life out there. How would meeting extraterrestrials change our perspective on humanity? Would it unite us or challenge our identity? Here is the wild idea. Some scientists believe we might already be in contact with alien life, just not in a way we expect. The theory of alien megastructures suggests that highly advanced civilizations might be building massive structures like Dyson spheres to harness the energy of entire stars. These structures could be far beyond our current understanding, making them impossible to detect with our current technology. If such megastructures exist, they might be silently orbiting distant stars, waiting for us to notice. In the search of extraterrestrial life, the Drake equation is often used to estimate the number of technological advanced civilizations in the Milky Way galaxy. It takes into account factors like the rate of star formation, the fraction of stars with planets, and the likelihood that life develops on those planets. Though we don't have definite numbers, it helps us realize that mathematically, the universe is likely teeming with life, though finding it remains a momentum challenge. Despite the Fermi paradox, the ongoing mystery, the search for alien life continues to grow. New tools like James Webb Space Telescope will soon give us even more detailed information about exoplanets and their atmospheres, possibly bringing us closer to the day when we can answer the ultimate question, are we alone? So what does all this mean? These all mysteries remind us that the universe is vast, complex, and endlessly fascinating. For every answer we uncover, 100 new questions emerge. But isn't that the beauty of it? Science isn't about knowing everything, it's about the thrill of discovery. So keep asking questions, keep looking up, and remember, the universe is out there waiting to be explored. The answers are out there too, waiting to change the way we see everything. If you enjoyed this journey through the cosmos, don't forget to like, subscribe, and share. Keep exploring and stay tuned for more. Take care, and we will meet in the next space journey.